Hello friends, in this session we are going to see some new topics related to enumerations, autoboxing and annotations. That is theory part 2 we are going to complete today. First of all, we will see type wrappers. Java uses primitive types such as integer or double to hold the basic data types. Primitive types other than objects are used for these quantities for the sake of performance. Okay, primitive types like integer, float and double are used rather than objects usage. Using objects for these values would add an unacceptable overhead to even the simplest type of calculation. Okay, if we are using objects for this simple types like integer, float and double, it will add the overhead in terms of efforts, in terms of time. The primitive types are not part of the object hierarchy and they do not inherit objects. Okay, they are separate types. They are not part of object hierarchy and they are not implicitly called as object. The primitive types are not part of the object hierarchy and do not inherit objects. Despite the performance benefit offered by the primitive types, there are times we will need an object representation. Okay, only for the performance benefit we are not using them as an object to save our efforts and save our time, for saving the CPU time and efforts. But still there are times where you will need an object representation of these primitive types. You can't pass a primitive type by reference to a method. Okay, for call by reference type you have to give the base class, that is object class, in which the integer or float has been declared. Also, many of the standard data structures implemented by Java operate on objects, which means that you can't use these data structures to store primitive types. Java itself operates upon objects. Okay, Java is object-oriented programming. Everything that you will write into Java program, that will be inside the class. Okay, without a class you cannot hold anything. That means without creating object instead of except static keyword, everything you will need to create an object, and everything that will be operated upon will be dependent on object, which means that you can't use this data structure to store primitive types. Okay, standard data structures, those are like linked list. Standard data structures like linked list and your array or array list, these will all operate upon objects, which means that you can't use these data structures to store primitive types. To handle these situations, Java provides type wrappers, which are classes that encapsulate a primitive type within an object. Okay, so primitive type will be wrapped into an wrapped within an object, and the resultant output is a type wrapper. Okay, like integer, complete name integer is an integer base class for primitive type int. Float, float, the F capital, is a base class or main class in which float type of primitive type are encapsulated. This way, the type wrapper classes are described in detail later, but they are introduced here because they relate directly to Java's autoboxing feature. Okay, so to understand first of all autoboxing, we have to understand first what are primitive types and what are type wrappers. For that purpose, we have introduced here the basic classes, basic detailed explanation of the primitive type and type wrappers. The type wrappers are double, float, long, integer, short, byte, character, and boolean. The names are same as your primitive type, like double. In double, the name of primitive type is double D small, and its type wrapper class D is capital. Floats, F is small, here F is capital. because it is a wrapper class. Like all the primitive type classes are created or wrappers are created like long integer, short byte, character, and boolean. These classes offer a wide array of methods that allow you to fully integrate the primitive types into Java's object hierarchy. Okay, like we have seen in previous slide that primitive types are not directly related to object. They are not part of object hierarchy, and they are not itself as object, but they can be wrapped into object, and they can be inserted into the array. Uh, they can be inserted into the type wrapper classes. So these are classes, and these classes offer so many methods. By using those methods, you will fully integrate the primitive types into Java's object hierarchy. Okay, so they will help the primitive types like integer, float, and double and boolean to come into the Java's object hierarchy. Okay, so whatever is we are explaining in the next upcoming slides. Character is a wrapper around a char. Okay, so no need to remember it differently. Just remember whatever is the name of your primitive type, its full name with capital first character will be your complete wrapper class name. The constructor for character is character ch. The ch specifies the character that will be wrapped by the character object being created. Okay, you are specifying here character primitive type and its object name that will be wrapped into a character. To obtain the char value contained in the character object called char value as shown here. Character char value. Okay, so which char value we have wrapped into the character class? I have to find it. For example, I created a character, suppose my name, and my name start with Suvarna, that is S. Okay, so I pass this S as in single quote with S. Okay, so this character class will wrap my character S into it. Okay, and if I want to find out later on which character I placed into that particular wrapper class, I have to find out it. For that purpose, I will use character value. So this character value will give me the character that is encapsulated, and it will return me S, capital S. Next, Boolean. Boolean is a wrapper around Boolean values. It defines this constructor. Boolean, Boolean value, string, Boolean, string. Okay. So Boolean is a base class, B capital. Around the Boolean values, it defines the constructor. First is for Boolean in primitive type. Second is for string primitive type. In the first version, Boolean value must be either true or false. Okay. Here you have to pass either true value or false value. In the second version, Boolean string containing true in double quotes, uppercase or lowercase, then the new Boolean object will be true. Otherwise, it will be false. Okay. If you are passing here in double quotes true in capital or small, it will be wrapping the true or false into Boolean wrapper class. Otherwise, if you are not specifying true, it will be storing the false value. To obtain a Boolean value from a Boolean object, use the Boolean value method. So it will give me if I am encapsulated true or if I am encapsulated false. It returns Boolean equivalent of the invoking object. Numeric type wrappers. Most commonly used wrappers are those that represent numeric value. These are byte, short, integer, long, float, and double. Okay, most of the times what wrapper classes we use? Byte, short, integer, long, float, and double. All of the numeric type wrappers inherit the abstract class number. Okay, so abstract class number is extended and implemented in all these classes: byte, short, integer, long, float, and double. Number declares methods that return the value of an object in each of the different number formats. Okay, if I want to get the value of particular object in number format, in byte format, in short format, or in float format, The number has already defined the method which is not implemented, and that method is implemented in all those classes particularly. In byte, it will give me the byte representation of that number. Short will give me the short representation. Integer will give me the integer representation, and so on. The methods are byte value, double value, float value, int value, long value, and short value. The double value returns the value of an object as a double, float value returns the value as a float, and so on. And these methods are implemented by each of the numeric type wrappers. Okay, because this class number is a wrapper class. This class number is a base class of this, and which is abstract. So these all classes have to implement it, and they have implemented it to have all these values. And this will return me particular value in particular format. If I am passing any number over here, it will give me its value in byte format, this value in double format. If I am passing over here like 123, its double format will be 123.0. If I am passing here 123 here, it will give me float representation. Okay, if I am specifying here 450.33, so its integer value will be 450 only. Whatever written after the dot decimal digit will be removed. Long will give me the long representation, short will give me the short representation of that particular number. All of the numeric type wrappers define constructors that allow an object to be constructed from a given value or a string representation of that value. Okay. All numeric type wrappers like byte, float, double, etc. define constructor. They have constructor that allow an object to be constructed from the given value or string representation of the value. Okay. The constructors defined for integer, num, integer, string. So you can pass the number over here, or you can pass the string containing the number. Like whatever string you are passing into double quote. Here you can directly specify like 24, and here 24 into the double quotes. If string does not contain a valid numeric value, it will give you number format exception. If you are passing here, I am very much happy, and you are trying to convert that string into integer, it will give you number format exception. If you have to have the integer value, you have to pass over in only integer into double quotes. All of the type wrappers override two string methods, that is byte, float, double, whatever the type wrapper classes are there, they override the toString method of the class. It returns the human readable form of the value contained within the wrapper. It allows you to output the value by passing the type wrapper object to println, for example, without having to convert it into primitive type. Okay, so if you want, they have already extended and overridden the method toString. By using that method, they print the value into string format, so that when you are printing your primitive types wrapper classes value, it will display that message without having to convert it into primitive type, directly using the wrapper class object. The following program will illustrate or demonstrate how to use the numeric type wrapper to encapsulate a value and then extract that value. Class wrapper, integer object is equal to new integer 100, I is equal to I object dot int value, displays 100. Okay, so I object is equal to new integer, so it will be an I object dot integer value. So here also it will display 100, here also it will display 100. This wraps the integer value 100 inside an integer object called I object. The program then obtains its value by calling int value and stores the result in I. The process of encapsulating the value within an object is called as boxing. This value, my simple value, I can declare it as integer I is equal to 100, semicolon. The same value I am putting it into object of this wrapper class integer This process is called as boxing. Boxing means my simple value I am putting into the box of the particular wrapper class. Okay, if I am passing the float value and I am putting that into the box of float base class float, that is wrapper class, that is called as, that process is called as boxing. Integer I object is equal to new integer 100 is the boxing procedure. The process of extracting value from type wrapper is called as unboxing. Unboxing will give you the primitive type value of that particular wrapper class. Like in I object, I have wrapped the integer value, okay, and its integer value will return me its primitive value, and that primitive value I am storing into the variable I. The same general procedure used by the preceding program to box and unbox values has been employed since the original version of Java. Okay, this process is used since the original version of Java, that is Java 1, 2, 3, 4 up to 5. Okay, and after that, with the release of Java 5, Java fundamentally improved on this through the addition of autoboxing. It is described into upcoming PPT slides. Okay, if anybody wants to box it, that is putting my value into its wrapper class called boxing. Manually it will be doing, he or she will be doing it. When he or she wants to get the primitive value from the wrapper value, it has to, he or she has to use this line, int I is equal to I object that dot int value. So this is the manual procedure you have to manually type in. But from Java 5, Java fundamentally improved the process through the addition of auto boxing. So it will be automatically boxed and automatically unboxed. Auto boxing. Beginning with Java 5, auto boxing and auto unboxing was added. Auto boxing is the process by which primitive type is automatically encapsulated or boxed into its equivalent type wrapper whenever an object of that type is needed. Whenever object of that type means object of int, object of float is needed, Java will automatically box into that particular wrapper class. And when its primitive value is needed, it will extract it and it will automatically unbox it. Okay, there is no need to explicitly construct an object. Auto unboxing is the process by which the value of a boxed object is automatically extracted or unboxed from the type wrapper when its value is needed. There is no need to call a method or such as int value or double value. The addition of auto boxing and auto unboxing greatly streamlines the coding of several algorithms. Okay, so each and every time you don't need to write code for boxing and code for unboxing, removing the tedium of manually boxing and unboxing. It also helps prevent errors. Okay, if accidentally you missed or you forgot to auto box or auto unbox, sorry, if accidentally you forgot to do boxing or unboxing, it will give you compile time error. So to avoid this error, Java 5 has already given the auto boxing and auto unboxing feature. This feature will eliminate your errors. Moreover, it is very important to generics which operates only on object. Okay, for the generics class that we will see in the upcoming chapters, this generics class operates only on object. Okay, so every time you have to convert, you will first of all create your primitive type. You will modify them, you will addition, subtraction, you will do all this stuff. But while using in generics and in generic class, every time you had to convert it into wrapper class before Java 5. But now, since Java 5 has introduced the auto boxing and auto unboxing, it will prevent error because you don't have to remember and manually auto box and unbox. Finally, auto boxing makes working with the collections framework much easier. With auto boxing, it is no longer necessary to manually construct an object in order to wrap primitive type. You need only assign that value a type wrapper reference. Java automatically constructs an object for you. Okay. What you have to do is you have to only assign that particular value. Which value? No longer necessary to manually construct an object in order to wrap a primitive type, and whatever value that you have to box or unbox to a type, whatever value that you need to box, convert to put it into the wrapper class, just you have to give only assign that particular value of int, float or double to a type wrapper reference, and whatever remaining task will be done automatically by Java. Okay, here is the modern way to construct an integer object that has value 100. Integer I object is equal to 100. So this value is automatically converted, automatically put or boxed into the type wrapper class integer. No object is explicitly created through the use of new. Java handles this for you automatically. To unbox, simply assign that object reference to a primitive type variable. Int I is equal to I object, auto unbox. Now we will see the detailed example. Auto box to int, auto box an integer value, auto unbox. Displays 100, 100. Now we will see auto boxing and methods. In addition to the simple case of assignments, auto boxing automatically occurs whenever primitive type must be converted into object. Auto unboxing takes place whenever object must be converted into primitive type. Whenever there is a must occurring, then auto boxing and auto unboxing will take place. Okay. Auto boxing and unboxing might occur when an argument is passed to a method or value is written by a method. For example, class autobox to static integer m. Here we are passing the primitive type and return b. It will auto unbox to int. Okay. So here I am passing returning from the method, but the type here it is expected to have integer wrapper class name, that is I capital INTEGR, which is I am passing over here. I have to return it, but still I can do it with Java 5. Why? Because of auto unboxing feature. Now pass an into m and assign the return value to integer. Now 100 I am passing to m. This is m. Okay. So while passing 100, I am not passing the object. So it will automatically box to integer wrapper class. Then while returning, it will be automatically converted to integer class. Okay. And system.out.println, this will be automatically wrapped to integer class. Sorry. First of all, step by step we will see what I am passing over here. Wrapper class value. What it should be? Wrapper class object that was created like this, but no need because it is automatically boxed to the integer wrapper class. Then it is passed to method m. What m is returning? It is returning with the primitive type. Sorry, it is returning with the wrapper class type. This wrapper class is auto unboxed to integer primitive type automatically here. And next, it is returning in integer, but it is storing into I object, which is wrapper class. So it is again boxed to the I object. So this all procedure is done automatically. This program will display the following output, that is 100. M specifies the integer parameter and it returns an int result. Inside main m is passed the value 100, which is not of integer wrapper class. It is the only simple integer value. Because m is expecting an integer, this value is automatically boxed to a wrapper class integer. Then M is returning integer equivalent. Okay, so how it is returning? V to be auto unboxed. Your wrapper class value automatically unboxed. This int value is assigned to I object, which is again the wrapper class, which causes the integer return value to unbox, autobox. Now, autoboxing, unboxing occurs also in expressions. Okay, autoboxing and unboxing take place whenever conversion into an object from an object is required. Okay, whenever you will require conversion into object or from an object, autoboxing unboxing will take place. This applies to expressions also. When evaluating expression, their output will be automatically settled. Within an expression, numeric object is automatically unboxed. Okay, numeric object like wrapper class double value, wrapper class float value, or in short, wrapper class float object, wrapper class integer object, wrapper class double object is automatically unboxed and given the primitive value to be calculated, like addition, subtraction. For that, you cannot operate on object. To add and 101, you cannot pass it as object and then you will operate upon it. Firstly, you have to convert it into primitive type. So conversion to primitive type and then addition and then again converting to wrapper class. This process is automatically done by Java. The output of the expression is reboxed if necessary. Integer I object to integer I. I object is initialized to 100. Original value of I object is I object. Then increment following automatically unboxes I object, performs the increment and then reboxes the result back into I object. Incremented after and displayed. IOB is unboxed, expression is evaluated and the result is reboxed and assigned to IOB2. Okay. IOB is unboxed. So its primitive value is first incremented and then stored. So value is 101. 101 plus 101 divided by 3 stored into I object 2. And output is stored into I object 2. Same expression is evaluated. Result is not reboxed. Okay. Now this value is displayed over here. Output is original value 100 after plus I object 101, after expression 134 and again after expression 134. In the program, pay special attention to this plus I object. The value is incremented. For that, it has to unboxed. I object is unboxed, the value is incremented and the result is reboxed. Auto unboxing also allows you to mix different types of numeric objects into an expression. So different values will be automatically unboxed and then evaluated and automatically reboxed if necessary. Once the values are unboxed, the standard type promotion and conversions are applied. Okay. So this way we have seen the different advantages of auto boxing and unboxing that is provided by Java 5. In the next coming session, I will try to finish all the remaining topics from this chapter, that is enumeration, auto boxing and annotation. So we will meet you in the next session. Thank you so much.